All right, let's go ahead and get started. It's a little bit loud, isn't it? Is that better? A little bit better? Okay. Hi, everybody.
Hi.
Welcome back. By now, you should have turned in your design document for Project 1. How many of you all got that done? How was it? Rough? It's a new way of thinking. How many of you all went ahead and just wrote the program too? Some of you all did? Yeah, sometimes it's easier to figure it out all at once. So, if not, don't worry. You still have a week to do it. Okay. And by now, you should have all the programming things that you need, except for possibly one thing, which we'll get to today. Is today Thursday? If not today, Tuesday. We'll get there. Okay. Any questions before we get started? Yes.
I have a question about switch case.
Yes.
So you can't have anything except an equal?
Yes. Switch only matches exactly. There's no way to have a switch statement where you say less than, greater than, not equal to. Only thing it does is equal, essentially.
So you would use an if statement if you had to have an
Yes. Or you can do something else, but yes, technically inside the switch case, you can only match one thing. If you had a range, you could make a list of like 10 things, any of which it match, right?
Yeah.
But you can't do greater than, less than, or not. So, yes? We're gonna talk a little bit more about switch statements today. So, yeah. There is not an else for switch, but there is a default. So if you have all the cases, at the bottom you will have a default which says if you don't match anything else, you can default to doing this. Default is optional, you do not have to have it there. Yeah.
For if statements, the computer knows like when it enters, okay, I know you're telling me the computer doesn't ever know anything.
Yes?
When someone enters like age like 14 and in your if it's like between 14 and like greater than 14 and less than 19.
Uh-huh.
You can do that.
Yes.
Knows how to do it.
We have told you how to use boolean operators that you would use. I haven't actually explicitly told you. I'm going to go back today and touch upon a few things in greater depth that we did before. The weird thing about this class is that it moves pretty fast, and so I have to like give you enough that you can get the project done early enough that you have time to do it, and then I kind of go back sometimes and touch in more depths on things. We're going to talk more about boolean expressions and switch statements today. So I believe that's going to answer your question. Yes, sir.
Is it okay if I program my code is different from an outline?
Yeah, I mean, it could be that you wrote your algorithm, and then when you started turning it into code, you wanted to change something. That's fine. The purpose of turning in the design document is for you to get thinking about your algorithm ahead of time, so that you're not doing it next Wednesday night at 1:27 a.m. Right? It's literally to force you to start early. That's the whole point of it. So hopefully you thought about it and you got some use out of it, and when it comes time to program, you can look back and start programming. But if you want to change things, we're not going to go back and like match what you said in your algorithm to your program and yell at you if you did something different. Okay. Unless you want us to. I offered to yell at you on the first day of class if you wanted. But are we going to talk about more about the concept? Probably not. Sorry. Yes?
I visited this meeting yesterday, and there was like a lot of confusion between them about like having constants in the outline we did.
Yep.
Versus actually putting it in our coding.
Yep.
And so they both like some of them are on one side and some are on the other.
Uh-huh. Well, you should point at the assignment thing that says you don't have to put constants in your code where it's on the web page. So, or if there's some sort of TA debate, email me and I will tell all the TAs the right thing to do. So, but in general, follow the instructions. The TAs are humans. They range from imperfect to less than imperfect. Yep.
So I just want to check both if statements and switch statements. The equivalent of an else is the first, which is kind of like the default, and both the else and default are optional.
Yes. Yes, sir. Yeah, it's okay. I mean, we're not going to take points off it. It was just there were a lot of constants to declare, and I was trying to save you some work. Did you find there were a lot?
Yeah.
So, yes. You can name it however you want. We're not specifying a naming scheme for the class as long as it's something that's understandable. The Google C++ coding style, which I will tell you about but not hold you to, says that constants start with a K and then after that they are camel case. So you have upper and lower case with no underscore. So that's how Google does it. They have, their own philosophy. I disagree with some of their stuff and their coding style, but if it works for them, I'm not going to tell them they're doing it wrong. Yep.
So for the problem, like the actual points for ages and the age ranges used are different. And so if, for example, we set low, base, and high for the bigger age ranges instead of the smaller ones.
It's fine as long as you're able to get it right. I mean, as long as your algorithm is right.
I'm just wondering like how malleable this program needs to be for future changes to get a good score. You know what I mean? Like I think your whole point about how
So there's a difference between me scoring things the right way and trying to teach you to do things the right way, right? When you write a history paper, do your professors take off for weird grammar? I actually don't know the answer to that. Do they take off for weird grammar? Oh, well, all right then. I mean, there's enough to learn in here that I'm just trying to show you how you use constants. And so if you look at other code, you'll see them, and we're trying to encourage you to do the right thing. You're going to develop your own programming style, right? Just like you have your own writing style. And I'm not trying to force you to do one particular thing. The one thing I'm trying to force you to do in your coding style is to make it clear for other people to read, period. You might develop your own, I have my own thoughts on how to do that, and I'm encouraging you to follow it, but you might develop your own thoughts over time as you read other people's code. But that is one thing a lot of people who come in programming don't bring with them. They bring a lot of experience in programming, but not a lot of experience in other people reading their code. Okay. Did I get locked out of my computer? Okay, so I have an announcement to make. This may not apply to most of you, but you might want to go anyway. Every year, the computer science department has a job fair. And at the job fair, we bring in people who are in local industry around the area who are interested in finding computer science students. We do this because the Career Center here is great. It's just that they're great for people who aren't computer science students because most people aren't computer science students. Even though very few of you, or if any, like one or two of you are about to graduate, right? You might want to just come by and stop by. What you will see at this job fair is you'll see a bunch of people from different companies. Many, if not most of them, are alumni from Georgetown. You can say hi, you can talk to them, you can say, look, I'm starting out in computer science, I've got this guy Clay, it's the worst experience of my life. I have no idea what's going on, it's horrible. I need a certain number of credit hours, otherwise I'm going to get thrown out of school. Should I stick with it? And you can hear their experiences, okay, and what they've done with their education. And they will, in general, probably tell you that this class is the hardest, it gets better after this. Okay. And if you don't want to go to the job fair, if there is a social event following the job fair at 4:30 at Epicurean, which I always call Epicurious because I wonder what they make their food out of, even though I eat there every single day. So you can just go to the social event afterwards and talk to people too. Okay. So I encourage you all to go. If you're all considering or just thinking about computer science, just go stop by and see what's going on. It's also possible for finding internships. Internships are good. Yes? Yeah? Well, free, funded by your tuition dollars that are, sent down to us. So, okay. Other questions? So anyway, I encourage you all to go to this. All right. Let's think back. You've finished your algorithm. Now we're going to do a program. What is a program? Yep. It's the algorithm that you developed your algorithm and now you're going to get the computer to do it for you. All right, using C++ in a way that people can understand. We've talked in past about Boolean expression. What is a Boolean expression? Yep, it's some sort of computation or calculation that tells you whether something is true or false. We talked about if-then-else statements. What do if-then-else statements make their decisions based on? A Boolean expression. Every if-then-else has a Boolean expression that tells it to do the then or possibly the else if you want to. We talked about integer versus floating point division. When do we do integer division with the slash? Yeah?
When they're both integers,
When they're both integers. What happens if one or another is a float?
it becomes a floating point division.
Everything is floating point. Yep. Okay, we talked about switch statements. A switch statement is a decision, like an if-then, except you're allowed to decide on many, many different things at once, right? You can give it a list of things and say, if you match one of these things, go to here and start executing. Okay, so it's kind of like a fancy if-then statement. As we mentioned in response to the question earlier, you can only match exact values. You can't do less than or greater than, but you can match anything in a particular list. All right. Now, I'd like to go back and talk about, in a little bit more detail, about a couple of things, just to cover things that I forgot or to talk about something else. So, if you remember this program, and I will turn up the font a little bit so we can see it, this was the initial program we ever wrote to do integer division, our first algorithm, right? And we decided that the way to get things to do floating point division was right here, right? Float result equals static cast float, dividend divided by divisor. And this static cast float, dividend, temporarily, for the purposes of this computation, turned dividend, which was an integer, into what? A float. We said cast this to a float, and cast means to change the type. Now, one thing I forgot to mention at the time is that this is C++ style. And we all know that C++ is the language that we're learning, but it's based on an earlier language which is known as C. Yep. And C had its own style for doing casting. And it was actually somewhat simpler. It was this. You just put float and then what you want to convert to a float in there. So what I'm going to do is I'm going to comment this out, and I will go and prove to you that this works. All right, it compiles correctly. Let's run it. I'm going to try integer or floating point. Floating point, because that's what we're messing on. 22 and 7. And it worked. Okay. So I just forgot to mention at that moment that there were two ways to do this casting, the C++ style and the C style. The reason I mention this is because I'm lazy, and this one's easier to write, and so occasionally it creeps into my code because I'm lazy and it's easier to write. And I didn't want to give you stuff to look at that had something you didn't understand. Okay? Yes, sir. It is functionally equivalent to this thing. Yep, absolutely functionally equivalent. As far as this class is concerned, there is no way to change the type of something once we have set it. Okay? Like you can't say int x and then later somehow magically make x a float. If you want to do that, you'll have to cast it and then store the value. Okay? No, permanently, I mean. Sorry, permanently. Some confusion. This will do it temporarily just for the purposes of computation, but there's no way to declare something and then change its type later. Okay? If you want to do that, do you want to see how to do that? Yes. All right. So let's call it convert type.cc. Pound include IO stream. What do you want to convert? Let's say we have an int, we want to convert it to a float. Int x equals 12, float f equals 0. So, oh yeah, that would help, wouldn't it? I don't have any candy today, I'm really sorry. So I just won't have to make any mistakes. All right, so one of the things we can do is we can just say f equals x. And what will this do? Yep. Yeah, This is essentially what will happen. The compiler looks at it and it goes, hey, f is a float, x is an int. This equal sign means to take this value from x and put it into f. The compiler will automatically do the cast for you. It'll cast this to a float and then store it in there. That's the best you can do. There's no way that I can tell you that we can say int x, suddenly make x a float instead. If you did something like this, is this what you're asking? X equals float x. Yes, here's what's going to happen if you type this. It's going to say, okay, I need to make x into a floating point value, and it will do that. And it will say, now I need to assign this floating point value to an integer. So it will convert your floating point back to an integer and then store it in there. So the net result will be nothing. So actually, let's try it the other way. Let me just show you something really fast here. Let's say we're going to do float is 13.78, right? And what happens if we do x equals f? Pardon? It'll become 13. So we have a prediction it'll become 13. That's a good guess. Any other predictions? It won't work. That's a good guess too. Yeah? Maybe it'll round up and be 14. It's not clear what it's going to do. I have a suspicion. Let's try it and see. All right, so here's where I compiled g++ convert type.cc-o convert type. Now I'll run it. And it converted it to an integer by lopping off all of the decimal points. Okay? Now, later we'll see some stuff about how to fix this. You might want it to round instead, right? But by default, if you assign a float to an integer, it will just lop off all the decimal points. Let's make this bigger. Let's just prove it's not really rounding, right? How's that? I'm not sure that's going to compile, but we'll see. All right. What? Okay. So here's what's happening is that it can be somewhat unpredictable, which means I will not ask you about it on the exam, right? What really happened here, I'll just tell you, is that when this was assigned, there is not enough space in a float to hold that many decimals. Right? Because remember, we're putting everything into one box in memory. There's not enough space to hold that many decimals, and it goes, well, closest I can get to storing that number you asked is 14. And in fact, if we tried to output f, I'm kind of curious. I'm winging it a little bit here, so let's see what f is. Any predictions on what it's going to print out? Yeah. So, yes, sir. Yep. Other questions? Yeah. Good question. Okay. So the question is, why don't we store all our variables as floats? Put a couple more 9s in there. All right, are those two things equal? Well, let's just take and see if the computer thinks they're equal. So we say if f equals g, and we think they shouldn't be equal, right? It doesn't look equal to you. Is that right? Oh, well, totally not going to be, that's totally not going to work then, huh? Sorry about that. I have to say, it's like hard to think about what you're doing and type and describe it all at the same time. So I normally fall down on one of those three. So, all right. Is that better now? All right. So should 13.99999 be equal to 13.99998? No, right? We all think it should be. Let's see what the computer thinks about it. It thinks they're equal. Huh? Yeah? Okay, so here's the deal. I'm going to tell you something that I didn't tell you before, but I don't mind talking about now because I was going to talk about it today. Okay? Each one of these, we put things in a box in memory, right? And each box in memory has a certain amount of space to store a number. Okay? When we talked about binary numbers, we talked about, I'll just draw it on the board because it helps make it makes sense, right? We had, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, and we could have binary numbers that matched each one of these powers. Everybody with me on that? So the question is, how do we store fractional numbers, right? Because this is great for integers, but how do we deal with fractions? Well, here's what happens. 2 to the minus 1, 2 to the minus 2, 2 to the minus 3, right? I don't know if 2 to 0 is just 0, so we even leave that one out, right? But 2 to the minus 1 is 1/2, 1/4, 1/8, and so on. So when we store a floating point number, it's represented in concept, all right? I'm lying to you a little bit so I can tell you about the concept. It's represented by a series of fractions. And what the computer does is it says, well, I only have 32 or 64 bits to store this. So there's only so much accuracy I can get by adding all these fractions together, right? Let's say right now we only had 3 bits. We had 1/2, 1/4, and 1/8, and we wanted to store the number 0.75. That would be pretty easy, wouldn't it? Because that's, 0.5, this one's 0.25, this one's 0.125, right? So if we do 0.75, that's pretty easy. How about if I wanted to store 0.7? Well, here are my choices. I could do 0.75, or I could do 0.625, assuming that I only had these 3 bits. So what happens is the computer has a lot more of these fractions to deal with, but not enough. Not enough to represent every single floating point number. So it rounds numbers, essentially. And it stores the number as close as it can possibly get, but almost never exact. And the reason we don't just store everything as floats is because when we get these rounding errors in the small areas, things are no longer going to be equal that we expect to be equal. Now, what I've just given you here, everybody kind of understand the concept of this, right? What I've given you here is like the broadest, biggest overview of this topic. When I was in graduate school, I took a semester-long graduate course on how to do math with binary, essentially numerical analysis. There's like a whole field to study how close you can actually get to numbers and how to measure the error so that when you do a whole bunch of calculations, you can tell like what range your answer is actually in because of this rounding error and such. But conceptually, here's the deal. Floats are great, but they become very imprecise and it causes problems. And I'm actually glad you asked me that because I was going to get to that later today anyway, but I kind of like doing it in response to questions. So, yes?
If you were just to store something that would have been an integer anyway, like 12 or 14, is that still going to be an accurate?
Okay, so if we were going to store something that was an integer anyway, are you going to be okay? You'll probably be okay. Probably. But every once in a while, what will happen is you'll do some calculation, and if you and an error will creep in potentially. If you're always doing it, then you probably won't have that problem. Other problems develop that way. So the rule of thumb is don't use floating point numbers when you don't have to, for you all. Okay? If you can use integers because otherwise you get weird things where numbers that you know should be different are not considered different because of rounding and when they store the numbers. Yes, sir. Okay, so here's the deal, and this, I'll just go ahead and talk about this. We've talked about a few different types in this class, right? We talked about ints, floats, bools, and what else? Characters, chars. Each one of these can be thought as taking up one memory slot. Okay? What happens in reality, though, is that one memory slot is not big enough to represent the numbers that we want to represent. So there are additional data types. And there are other data types that give us better precision. So for example, a float can be considered a number that is stored in one memory slot. If we use a double, that says instead of using one memory slot to store the number, use two. Instead of having, say, 32 or 64 bits, use 64 or 128, which means that these fractions conceptually can get much closer. And I'm willing to bet, now that I've changed this float to double, I bet it's going to work. I'm not entirely positive because I haven't tested it, but now they're not equal. And the reason is that now we're using doubles. We have enough precision space. Okay. Now, if we want, we can, go be jerks. And we can actually, figure out kind of where double stops working on this. So if you weren't looking, what I did is I put a whole bunch more 9s in here. And I changed the type of f and g to double, which means instead of storing the number in one slot, store it in two, gives you more space, gives you more precision. Let's see if adding those extra 9s beat it. Now they are equal again, okay, because of rounding error. Okay, so floating point numbers have this problem where there's this rounding error, and you're limited in how precise you can be. Yes?
Can you just continue to increase the number of boxes you do that?
You can increase the number of boxes. You absolutely can. So, and I'll do that in 1 second. Yes? Okay. Calculators, some calculators work differently. Like a TI calculator works on like trinary or quaternary numbers. It's not all binary. But yes, they keep very large things. So I've shown you doubles. There's also something called a long double. If I could type, there would be something called a long double. I still can't type. And I've lost my program. All right, long double. Okay. A long double, so float says use one box. Double says use two. Anyone want to guess what long double uses? 4. So I think now that if we do this, if I didn't screw something up, well, maybe that's still too precise for our long doubles. And I'm lying a little bit because, long double probably isn't very different than double on this. Because of the way the computer works. There's the convention of how you think about them and what the computer is actually doing, and they differ from computer to computer. So, there are a bunch of different types. All right. If you want to go beyond 4 boxes, you have to use a special library for that. It's called a big number library, and they allow you to use an arbitrary number of boxes to store numbers, and you can be arbitrarily precise. That's kind of outside the scope of this class. Those things are used a lot in like cryptography, where if you're using cryptography, anybody know about cryptography? You're encrypting things, and in fact, a lot of things on the internet are encrypted, and some of the math that behind the cryptography uses very large numbers, like hundreds and hundreds of digits. So the big numbers are used for that. Everybody with me? So I didn't really mean for this to turn into different types, but let's talk about different types, okay? Okay, so for floating points, we have what's called float, which is the smallest, double, and long double. So far in this class, I have been using float. I recommend that you use double in your programs. The reason I've been using float in this class is that eventually we would stumble across something going wrong, and I would be able to talk to you about the difference between float and double. But I recommend using double in place of float. Double for most of us will be more than enough precision than we'll ever need. All right, for integer, we have something that's called a short, which is like a smaller integer range. It's very rarely used these days, but you might run across it. We have an int and we have a long. And long is essentially short for long int. The other thing about integers is that what numbers can an integer represent? Decimal numbers? Whole numbers? How about, do they represent negative and positive numbers? They do. But you can make it so that things, oops, I don't know. So that integers do not have any negative numbers. So if you know that you're dealing with an integer that will always be positive, you can make it unsigned. And unsigned means always positive. The thing about unsigned integers is, you know, if we can represent from minus to a particular number to a particular positive number, if you unsign it, you represent it from 0 to 2 times the positive number. Right? So it gives you additional range. In this class, we're probably not going to use these. I just really wanted to give them to you in case you saw them. Yes?
So where does the, when you're writing the program, where does that design come?
If I wanted to declare x as a positive integer, and it will always be integer, I would, if I could type while I was talking, I would say unsigned int. And if I compile, that should work correctly. Let me just check and see, because yeah. Yes? Short essentially says use 1 box to hold an integer. Int says use 2, long says use 4. Most computers these days, there's no difference between a short and an int. Like this came back, this is a kind of convention that arose when computers had very narrow number representations and were less powerful. But what's happened over time is they've gotten more and more powerful, and as they've gotten more and more powerful, the need for some of these smaller things has gone away. A float you can think of as 1 box, as a double is 2, a long double is 4. I'm lying to you. It's not always that way, but you can think of it that way. Right? It varies from computer to computer. If you go out and you start programming something like, I don't know, like the Nest thermostat or some sort of embedded device, these things will probably be very different. On your laptop computer, there won't be a lot of difference between them. So, okay, but this is the convention, and if you read code, you'll see it. Unsigned means, okay, and then we have a couple of other things too that get a little bit strange. So we have a character, right? A character holds 1 thing. You can also have an unsigned character. You will see that sometimes. I'm not going to go into what it does because it doesn't matter in this class, but if you see it, you at least go, oh, Clay told me that that existed, but I still don't know what it is, damn him. Right? So, all right, so these are all some different data types. Oh, we also have bool. And do we need a long bool, a double bool, an unsigned bool? No, we only have true or false, so that's the only thing we have in there. All right. Okay, so everybody kind of good on this, right? You can see that floating point numbers have this problem that there's rounding going on down at the lower decimals as they're stored. You can see that if you are trusting them to be equal, sometimes they will not. And you can see that we can expand the storage space to add more precision. Right? We can give it more memory slots. And there's a bunch of different types we'll use. Most of the time in this class, we will use int, float, or double. For your programs, I recommend double. We probably won't do anything unsigned. We'll use some characters, and we'll use bools. Questions? Everybody happy? Yeah? A bool is a variable that only has true or false. So we need very little space to store a bool. Yes, sir. We'll get to those. We'll get to those. So far, all we've talked about is character that has like 1 character, right? We don't really often just use 1 character to communicate unless we're texting. So we normally use like a whole bunch jammed together. Those things are called strings. It refers to a string of characters, like you string them all together. And we will talk about strings, probably not this class, but next class. Okay, and we'll tell you how to jam all those things together. All right. Everybody good? Take a little break, stretch for a moment. Yeah. There is no type string, but I'll talk about that later. No, I'm sorry, I'm not really taking a picture of you. The memory card got full, so I'm just deleting some old stuff, and I had to turn the camera around where I could get at it. So.
They're all the posters, and it's above that, and it took up the entire wall. So it's kind of questionable. But
All right. So one more thing that I'd like to go into in a little more detail we talked about, but that which I didn't really do a full justification of, is talking about a little bit more about Boolean operators. Okay? Boolean operators are things that allow us to check whether something is the true or false or not. And I haven't given you kind of everything you need to know. So let's go through and talk about the ones that we know. Equal, equal. What does that do? Equal, equal checks if things that are equal. What does equal do? Is this a Boolean operator? Okay, I just don't want you to get those two mixed up. You probably will. People typo these in if statements and bad things happen. Okay, and we learned not equal, right? What other things do you think there might be? Greater than? Is that greater than? Yes. It's very specific. Exclamation point equal. Bang equal. Not equal. Okay? This is greater than? Yes. This tells you we're going to test some of these as we go along. This I didn't hear who asked that question. But this will say if you have two things, it will be true if they are not equal. Sure. So that's greater than. If you want greater than or equal to, you do it this way. So it's the greater than sign followed by the equal sign. Yep. The same thing holds from less than. So we can do less than. Let me just tell you, I'll tell you something right now. Do not try doing this. Equal, greater than. That is not a Boolean operator. It is something that is valid in C++ and will not do what you think and will produce crazy output error results. Okay? We will learn about this operator later in the semester. Okay, and we have a couple. We have and. And how does and work? True if and only if both are true. What else do we have? True when? Yep. And there's one other one that we need to know about, which is actually pretty useful, which is not. You just put an exclamation point in front of it, and it flips whatever follows that. Right? It just changes it. So you can have a test, and you say if these two things are equal, it'll say true, and then you put a not in front of it, and it says false. I will demonstrate some of these now. It's useful because sometimes it is easier for us to think in terms of if you have things that you're comparing equal. You want to know if it equals this or this or this, that's one thing. But if it's not equal to this or this or this, you can just say not this or this or this. It's the equivalent of saying, not equal and. Like there are ways of writing equivalent things. It's just sometimes easier to do one way or the other. And I'll demonstrate some of these now. Okay. So these are the Boolean operators that we have. And some of these we've seen before. So up here I declared a few variables, right? A Boolean be true, another Boolean be false, integer 1 equal to 1, integer 2 equal to 2. And now we can test some of these things. What do you want to try? Anything? Counting on me to do this, huh? Okay. All right, so we can say 1 equal to 2. Then we can say out, math is wrong. Okay. So do you think math is wrong? Who thinks math is wrong? Yeah, it's not wrong. We did not put anything. Okay. So there's equal. How about if we say not equal to? Should 1 be not equal to 2? All right. In which case math is right. That's good news, isn't it? How about is 1 greater than 2? Yeah. Oh, sorry, I went really fast. I just made these integer variables up here. Is that why it was confusing? Sorry. I could have used the actual literals, yes. So I just made variables out of them. Sorry to confuse you. Listen, if I start running off full steam ahead somewhere and I'm leaving you all behind, yeah, just let me go. No, let me know, right? I'll come back and get you. Seriously, because I know this stuff. There's no point in me talking to myself. So if I'm leaving you behind, if I've done something, it's fine. I go fast sometimes, and the reason I go fast is because I've been doing this for a long time, and these things are easy for me. And the hard part of my job up here is remembering how difficult it is the first time you see it. So look confused, say something. There's a few people in this class, I've already picked you out, who wear their expressions on their face very well. And I tend to look at them a lot to see, that's how I kind of judge what's going on. And then there's some people who look happy all the time. And if I'm not looking at you, it's because I think you had a bunch of cough syrup this morning and you're not really paying attention anyway. Okay. But if I'm running off, please stop me. Seriously. Like I did. So let's just go back and look. I created 2 variables, true and false. I created 2 ints, 1 and 2. And then I typed out all these comments, which hid these variable assignments from you. So it was perfectly sensible that you didn't see them. Everybody with me now? And you're going to keep me from running away in the future? Okay. All right. So is 1 greater than 2? Generally? Not even for very large values of 1? And very small values of 2? You think I'm joking, but if we start doing this in float, that can actually become, that greater than can actually become true, but weird things happen. Weird things happen. And sometimes they happen not on the computer, but in hardware. A number of years ago, the Pentium chip had a math error, and I can't remember what it was, but it was 2 + 2 = 5. There was just weird stuff going on, and they had to fix it. It was horrible. Anyway, so 1 greater than 2. If that's the case, math is wrong. Otherwise, let's put an else in here. All right, so if 1 greater is 2, math is wrong, otherwise math is right. That seems correct, isn't it? I will tell you also in class, I'm going to always get these things wrong. Greater than or less than, for some reason, even when I stop and think about them, I get them wrong. I'm almost to the point now where I'm going to like think about it and just do what I think is wrong every time, and I'll be more right off. And I don't know, I have some sort of mental blockage about that. So is 1 greater than 2? Nope, math is right. Because 1 is not greater than 2. Is 1 less than 2? Yeah, stuff like that. So you kind of see how these work? Yes. I know I'm going fast because it's easy. Yes?
Could you show one with less than or equal?
Sure. Sure, let's get another variable. How's that? So what I did is I added another variable 3 that stores 3 in it. I said, is 3 greater than or equal to 1 plus 2? And if that's true, math is actually right. So here's what I'm going to do. Rather than switch my statements around, I put a not in front of there. So if it is not the case that 3 is greater than or equal to 1 plus 2, then math is wrong. Otherwise, math is right. And I screwed up something. Oh, because I need to put parentheses around that. Sorry. Sorry, I went crazy. Sorry, slow down. Okay, so I was asked to do if 3 is greater than or equal to 1 plus 2. Is this true? Is 3 greater than or equal to 1 plus 2? What's 1 plus 2? Is 3 equal to 3? So the equal part is true, right? The greater than part may not be true. So the problem is that I had my statement switched. So if this was true, it was going to say math is wrong. Is it wrong that 3 is greater than or equal to 1 plus 2? It's not. So instead of flipping my cout statements around, what I did is I just put a not in front of there. So what this is saying is if it's not true that 3 is greater than or equal to 1 plus 2, then math is wrong. Right? If it's not true. And I compiled it like this, and then what happened? It barfed. The compiler barfed on me. Right? What? Oops, I forgot to save it. So let's make the compiler barf again. And here it is, and it barfs out all the stuff. And when we debug, right, when we debug, what do we look at when we're fixing? Only the first line. Don't look at this other stuff, okay? Because what it says is expected a parentheses before the exclamation point. We go, okay, that's actually helpful. So I'll put a parentheses in front of there. I'll go to the end. I'll close the parentheses so that they're always balanced. So now what we're saying is if it's not true, that's what this not is, that 3 is greater than or equal to 1 plus 2, then we will say math is wrong. But if it is true, we'll say math is right. Yes, sir? Okay. Yep. Yep. No, I mean you can have kind of whatever you want. Yes. So, I mean we could do something. So here's our math example. Everybody good with the math example? Even though I went barreling off into the distance again somewhere. Yep. Everybody good with the math example? So, and this says if here, this is a Boolean operator. It compares this side with this side. It does this math first. It says 1 plus 2. It says if greater than or equal 3. 3 is equal to 3 once we add 1 plus 2. So we're good. So this becomes true, but I say if it's not, which flips it, which means it becomes false, which means we go to the math is right branch. Got it? All right. So the question is, what if we're not doing math stuff? And the answer is, it doesn't matter. Up here I have a couple of things with true and false, right? So, we can do something with true and false too. We can say if true we can output true. Otherwise, what we're going to do, nope, I just put true as a message there, like as a inside double quotes. This is what we're going to print out. Now, it's not intended to be the true and the if. I meant just to be true, because sorry, I'm trying to talk and do things at the same time, and obviously I suck at that. All right. Up here inside the parentheses is a Boolean expression. What does a Boolean expression always return? True or false. Is true one of true or false? So you can just type true right in there. Now, in this case, what will happen is that this will always be true. So when will it ever print out the false stuff? Never. It will never. Okay. Well, let's put, you're absolutely correct. If we put not in front of it, it will always print out the false and never print out the true. But the way it is right now, it just says true. So it's going to print out every single time we run this. You know what else? I'm going to comment this stuff out so we don't have to look at it. I'll do it by hand, I guess. Okay, so we compile this. Now what's this going to print out? Any predictions? You sure? How about if we run it again? All right. No matter how many times we run this, and I just told the computer to run it over and over and over and over and over and over endlessly, this is always going to be true. All right? Always. What? It's still going. Yeah, you can see it's just flickering down there at the bottom one. So, yeah. So anyway, I just wanted to show you that no matter how many times we ran that program, it would always be true. Always, every single time, endlessly, which is a really boring program, right? How about if we put a not up here? What would happen? Yeah. Okay, how about if we did this? You sure? True or false is true. Yeah. How about and? False. How about this? Okay. How do you know? Yep. I should say this then. False. How about this one? All right. I think it's false. Yeah. I think it's false. So here's the deal. You can string these things together with ands and ors. And I'll just tell you the way it evaluates it is from left to right. So it assumes that one's with that, it does this one first, it does that one with that. All right? But it's not immediately clear that it does that. So let me encourage you that if you're writing these statements, to do parentheses, because parentheses will force evaluation in the order which you intended. Okay? It'll do the things inside parentheses first, and it's much clearer to read. Yes? There is, and we're going to get to that when we talk about math operators, which I've just been going off on random tangents, but we'll probably get to it today, maybe, or next week. So. Okay, so everybody kind of good with Booleans? Yes? Okay. Why is it evaluating true, false? Because here's what happens. It says, okay, I have all these things in a row. I have to evaluate them from left to right. So from left to right, I have true and false. And what is true and false together? False with and. If anything is false, the whole thing's false. And then it ends up with false or false, because after it evaluates this part, it has this whole thing becomes false. And false or false is false. Yep. Okay. So everybody kind of good with Booleans? They're straightforward logic. Oh, one thing I do want to mention. And I want to mention this as a warning. I want to point this out as an abomination. I want to tell you you should never, ever do this. Is that there is another way to write if statements. And it is called the conditional operator. Let me just comment this out first, and I will show you the conditional operator. Why is my keyboard not working? Yes, sorry.
So that, so once you have the correct parentheses and everything, what does that return? Does that return true or does it return false?
This whole thing returns false. Because true and it goes from left to right, and it says true and false. If you have true and false, that is false, because both things in the and have to be true. And then you end up with false or false, because it's evaluated that to false. Does that make sense? All right, so there's one more way to write an if statement. And it's like this. It's horrible. Let's do it this way. Okay, let me just make sure this compiles, because I actually never ever use this. Ha. Let's see. True. I think this has to be all in parentheses. All right. So there's a way to write an if statement. And the way you write the if statement in a very condensed form is you use this question mark operator. It is called the conditional operator. And here's what happens. We're trying to output something, and in some cases it's going to be true, in some cases it's going to be false. So here's how it works. You have a boolean expression, which I've just put true here. The question mark, what happens if what you use, or what happens if it's true, a colon, what you use, or what happens if it is false. This is a very condensed way of writing an if statement. And then this is how people often use it if they're outputting something and they just want to write one output line. Okay. This is a tool of the devil. It's very commonly used. People like it. I would really encourage you never, ever to use it as long as you live. Okay. And the reason is that in my opinion, I hate these things. It makes your code harder to read, right? Because you've taken several lines and you're coming along and you say, okay, if, here's what we're going to do, otherwise we're going to output this thing, and you've condensed it into such a tight thing that somebody who reads your code can have difficulty seeing what you mean. How many of you have ever programmed and used this before? Nobody? Good. Your hands are clean. So, and you know, so just, you might see this, but don't use it. Just explicitly make it if or else. Okay. Everybody got that? All right. This is what? A tool of the devil. Repeat after me. This is a... Thank you. All right. But you need to have it in case you ever see it anywhere and you go, what is that thing? If you see the question mark, you realize that it's a tool of the devil, and the programmer who wrote it is one of the devil's minions, because you know there's actually quite a number of people who use this. So. Okay. There we go. All right. Questions on Boolean? This is the conditional operator. Never use it. It won't be on exams. It's a tool of the devil. All right. I want to go back briefly and talk about switch statements as well. We were introduced to switch statements. Oops. And let me just write a little program here. Do y'all want to talk amongst yourself for a second while I type up a little program? Do you need a topic of conversation? Would military intervention in Syria be justified under the just war theorem? Go ahead, discuss among yourselves. I'll be back in a minute. All right. Welcome back. Welcome back. Break time's over. So, I wanted to talk a little bit more about switch statements. Okay? And so I wrote this little program here that, given a grade, can tell you essentially how you're doing. Right? So here's our program. I have all the stuff up at the top, pound include IOStream using namespace standard int main. And then we have this other stuff, which is defining a variable, a character variable named grade. What is a character? What is a character? A single letter, absolutely. And we're saying C out, enter a grade. And then we say C in into grade, and it'll enter into the grade. And then we switch based on what the grade is. And we can tell people, you rule, you're pretty great, you're doing okay, you need to come to office hours. If you get an F, this rarely happens. And default, I don't know what your grading scheme is. Okay. Make sense? Yes, sir. Other questions? Yes, sir. No, it's neater. It's neater in input not to have it. It doesn't really matter. Okay. So I had a question about break and what's going on here. So let's compile this and see if it works, because, I didn't. All right, so it compiled correctly. And let's go back and look. So here's what we expect to happen. We'll get an output message that says, enter a grade. We will type a single letter, which will be accepted as a grade, and then it will tell us something about our grade. Right? All right. What could possibly go wrong here? Anything? It could. Let's see what happens. All right. What grade do you all want to get in this class? All right. Oh, A, sorry. C. Hey, yeah, just set that low floor for yourself. Okay, so we enter a grade, and what do we expect it to tell us? You are awesome. And what do we get? You rule, you're doing great. Okay. It actually told us every single one, including the default one. So here's how a switch statement works. A switch statement works by finding the thing that matches and then just running all the code that is underneath it. Okay? Running all the code that is underneath it. How do we stop that from happening? Yeah. Anytime you, and this is called falling through, okay? So if we match an A, it will print this out, and then it will fall through whatever case is underneath there automatically. Okay. It will fall through, unless, yes? Yeah, let's try that. That's a really good thing. We'll try what happens. So that was what happened with an A. Let's try a C, in your honor. What's your name? AJ. AJ? All right, AJ, the C student. You're doing okay. You need to come to office hours, though it rarely happens that people are doing okay. Come to office hours, and I have no idea what your grading scheme is. Okay. So what's happening here is it seeks down, essentially the computer, being a dumb, remorseless calculating machine, just goes, is it an A? No. Is it a B? No. Is it a C? Aha! From here, I just start executing code. Right? And it says C, I'll start doing this, I'll do that, I'll do that, I'll do that. Oh, I reached the bottom of the switch statement. Okay. So the break, which we showed you like last time, is very important. Where would we put breaks in here in order to make it function the way we expect it to? Yeah? After each C out, we would need a break. Okay. We do not need one after the default, because once it reaches through the default anyway, it stops. So let's compile this and see if this does a little bit better than we expected. Okay. All right. AJ, in your honor, C, you're doing okay. All right. Any other grades we want to check? A, you rule. B, you're pretty great. You got an X grade. I have no idea what your grading scheme is. 12? I have no idea what your grading scheme is. Yeah? Who wants to shout out numbers? Who has a question? You want to shout a number? Go ahead. Oh. All right, well, so I didn't include that in there. If we wanted to have it so we could have both upper and lowercase, here's how we do it, right? It matches exactly, so we can also put lowercase, and it will match either on the A and fall through or the lowercase a and start executing. No, you cannot have ranges on here. You can only have absolute exact matches. And the matches can only be characters or integers. And the reason they can only be characters is because character is really an integer. It's just hiding the fact that it's an integer from you.
What if we wanted to check other grades like A minus? Is there a way to do that?
No, not using a character. No, there's not. Very easily. I could hack something up, but I don't want to get into it. So it's single characters only for switch or single letters. A minus would require 2, which would be bad. Yeah.
Can we put like a number like a 95 and like for like to tell us like would it like identify for example as an A or
Okay. If you really wanted to do this using numbers, remember a switch statement has to have exact matches. So if we wanted to do this using numbers, how many of you want me to keep going, right? So you can use exact numbers, except this isn't quite right because it's looking for a character and these are integers and weird, bizarre things are going to happen. But there's no way to tell a switch statement to use a range other than explicitly listing out every single number you want to check. The nice thing about switches and the nice things about if statements is that you can use either one, whichever one is easier. If you're going to check a range, an if statement is much easier. Right? Yes? I took them away because I was just demonstrating how I would do it. No, there's no quotes around the numbers. There is a quote around the character because it's a character and that's just the way character magic happens. But if you have numbers, if you were doing an int, you would just have a number without any quotes around it. Yes? You can have as many of these single labels as you want within range. So okay. So if you're doing, yes, you cannot have more labels here than you have individual characters. That is correct. There are more than 52 characters, but we haven't talked about that, and I don't want to get into that right now. Okay. If you're interested, the thing to Google, look up ASCII, ASCII. Here's what's happening, right? When we have characters, what does the computer run off of? Ones and zeros? Everything is math? Is a character math? It's not, right? So what happens is these things are actually a code. These things are actually a lookup in a table that tells you how to convert what number to what letter. And for this, it's probably ASCII, ASCII, which is a small table of lookup. If you're dealing with foreign languages, they also have other things called UTF, which have tens and hundreds of thousands of different possible characters. Yeah, crazy stuff. Crazy stuff. One more question? Yep. Yes, you could have 5 as a character rather than a thing. So if you went to school in like India or England or something like that, where they had a different grading scheme where 5 was an A, you could also put a 5 in there. But you'd have to put quotes around it, and this means the character 5, not the number 5. We'll start next class talking about that. So. You can store integer as a character. You can store a single digit of an integer as a character. But it's different. It's not, at that point, it's no longer an integer that you can add. It's a character that weird things will happen. So. What? I'll email you about it. So, Yeah. Yes. I put all the code